Alright, let's just do some exam papers. This is part B from an OCR Gateway paper. You can download it below. Go try everything first before you watch, so that you learn more effectively. We did part B the last time, and we will do part C soon. So the first part of the question, you're given a table with different materials, their state, and their density. And I want you to describe any trends in the data. Okay. Even if you think you know nothing, try your best to write an answer down now. Okay, trust me. Okay, so without even knowing what any of this means, you can still answer this by highlighting the different states. So argon is gas, and so oxygen. Then copper into solid, and so iron. And finally, ethanol and water liquid. Pause now if you still do not see it. So immediately, you can see that gases, whatever they are, have the smallest number in this column, density. So the way you would say that is gases are the least dense. And then solids have the biggest number in this column. So you could say solids are the most dense, or solids have the highest density. And those are 2 marks right there. You've got everything in the question. You don't need to write more. What you could have also said, if you wanted to, are that liquids are less dense than gases, or less dense than solids, sorry, but more dense than gases. Okay, but let's try and get some intuition for what is actually happening in the question. So to do that, you can use the particle model. So everything's made of particles, and for simplicity, we pretend that they're all small, hard balls. They're not, but this is still a good way to think about it. And some things are solid, and the particles are really close together, and they've got strong forces holding them together. So you can't push them out the way. Some things are liquids, and the particles are further apart, and the forces holding them together aren't as strong, so the particles can move around each other. That means you can push them out the way. And lastly, there's gases, and they're extremely far apart from each other, further than I can show here, and moving gases out the way is easy. But the question has this column, density. There's a property of all substances called density. And it's basically how much of it can you fit in a certain amount of space. But let's be exact, because we're not being good scientists if we're not being exact. So density is defined as the mass per unit volume of a substance. So if I pick a volume, let's say this square, and I check the mass of everything in it, then I can calculate the density. So what this table shows, if it shows how much kilograms of a substance you can fit in a meter cubed of space, you can see that copper atoms are really close together, so you can fit a lot of them into a small space. Ethanol isn't as heavy as copper, and it's also a liquid at room temperature, so the atoms are further apart, so there's less mass in the same volume, so density has to be low. And then finally, argon is a gas. The particles are so far apart, the density is tiny, because the mass is so small in that volume. Boom. All of this makes sense now. Let's move on. The second part of B then asks you to explain the difference in density between solids and liquids, and that you may draw a diagram to help your answer. And that basically means that you should be drawing diagrams. So, do it now. Okay, so if I show you all of this information, then you can definitely write something down. So mass is like the amount of stuff, how heavy all the stuff will be, and volume is the amount of space. Now you can clearly see here that because particles are more tightly packed in a solid, you can fit more mass in the same amount of volume than in a liquid because the particles are further away. Okay, so particles are more tightly packed in a solid than in a liquid. So you can fit more mass, more stuff in the same volume, same amount of space. This makes the density higher. And we can add simple particle model diagrams here, like this. And this is going to be my solid. And the particles are going to be tightly packed together, so you can fit loads. And this is going to be my liquid. Particles are further away from each other, so you can't fit as many in there. And that's it. That's done. That's all the marks.